Hello everyone, now we are going to see about memory mapping in MSP430. MSP430 follows one Newman architecture, which means that the entire memory will be in a single block. This block of memory will be connected to CPU through buses. So MSP430 follows 16-bit addressing. Next, 16-bit in the sense 2 power 16 is equal to 65,536 bytes of memory. So 65,536 addresses can be utilized for 64 KB of memory space. The address which starts from 0000 to FF hexadecimal value. So now let's see how the entire block is classified for different purposes. So first function is a special function registers which are of 16 bytes, or we can say it as 0f in terms of hexadecimal. So here the starting address is 0000 to 000f. Special function registers are utilized for enabling external modules as well as signals where the bits related to the interrupts are utilized in these registers. So the next section is peripheral registers, that is byte access, where the starting address is 0010 to 00ff. So here peripheral registers of our byte access consist of 232 bytes, or in terms of hexadecimal we can say it as EF. The next one is the peripheral registers which are used for supporting peripheral functions related to the input or output port. So next one is peripheral registers with word access, where it consists of 256 bytes, or in terms of hexadecimal we can say it as FF. So here same starting bit of peripheral registers for word access is 0200 to 027f. So the next one is RAM, that is random access memory, which allows the user to store temporary variable. Here the total number of bytes is 128 bytes, or in terms of hexadecimal we can say it is 7f. Here the starting address is 0200 and the ending address is 27f. So if the RAM were to be expanded, it has to be expanded to the higher versions, that is a higher region. So the next one is a Bootstrap Loader, where here the starting address is 0600 and the ending address is 0FFF. So here the total number of bytes occupied is 16 bytes, or in terms of hexadecimal we can say it is 3FFF. So Bootstrap Loader which is utilized to load OS into the memory, and it also does post. Post in the sense power on self-test, the software tool can perform upon itself. So the next one is flash information memory. Here the total number of bytes occupied is 256 bytes, or in terms of hexadecimal we can say it as FF. Here the starting address is of flash information memory is 1000, and our ending address is 10FF. So it is meant for storing some settings that is adapted by the user upon embedded system. Okay, next then there is some empty space followed by two sections, that is flash memory. In flash memory, that is divided into two parts. One is flash code memory, and the other is interrupt reset vector. The flash memory, which occupies 2 bytes, 2 kilobytes, or in terms of hexadecimal, we can say it as 7FF. Here the starting address for the flash memory, combined flash memory is F800 to FF. So the 2 kilobyte consists of code memory, and other is interrupt or reset vector. 1 kilobyte of flash memory is for storing program. So that is a flash code memory. So other 1 kilobyte is for providing vector addresses. That is for interrupt and exception mode of operations in the embedded system. That's all about memory mapping in MSP430. Thank you.